Okay, looks like I got two more examples on this section. So just make sure that you are working through them. You might have tried this on your own. That was just sort of up to you. I think that we're looking at some slightly different stuff here, so it might have been a little too much for you to go through and do on your own. But what we're doing here is we've taken the ideal gas law and we've just rearranged it. That's all that's going on here. This is simply rearranging the ideal gas law. I mean, that is literally all that's happening here. So let's kind of take a look at that. So here's the ideal gas law with an actual pen. And we think about density and molar mass. This value here, the N, we can kind of break that down into, okay, well, moles is grams divided by molar mass. So if you think about it this way, where we're going to take the N and we're going to replace it with the fact that moles, we're going to take our grams divided by the periodic table number, which is M. So M is going to equal molar mass. So M is molar mass. So that's what you get from the periodic table, right? So if you don't know what that is, it's just like, okay, carbon's got a molar mass of 12.01. So grams divided by molar mass. And so then you have this formula, PV equals GRT divided by molar mass. Then what this is simply rearranging this formula here to find molar mass. And so if you think about how we rearrange a formula, then I can just put the M and the PV, they can swap places. M up here, PV on the bottom, and then there you go. That's this formula, which is molar mass equals GRT over PV. Now notice that I use the lowercase m there instead of G. You can replace that if you want, but I replace that M because M is mass, but I just replace it with G for grams. I think that might be kind of useful. So anyway, that's the formula. So let's not do that. Let's go ahead and slide down here. Calculate molar mass if 0.4 grams occupies 179 milliliters at 98,475 pascals and 86 degrees Kelvin. So they're kind of giving it away, right? They're like, hey, find molar mass. And so we're going to go ahead and use that. But we've got this situation here with the pascals. And so on your pascals, you're going to need to have your conversion. So on the conversion, the way I kind of think of it is like this, is that 1 kilopascal equals 101 ATMs. Now, it's a little bit more specific than that. It's 101.325 ATMs. But if you just remember the 101, then you'll get the problems close enough, right? So that's a pascal. So what we can do is you could take 98,475 pascals. We could then convert them into kilopascals. So every 1 kilopascal is 1,000 of the regular pascals. And then we can convert the pascals into the kilopascals, into ATMs. So let me clean that up real quick. I need a little more space than that to make sure that looks right. Now, you don't have to do this. You can just use the conversion that they give you, but I just really like working in the ATMs because I think that the students are more familiar with it. So it looked like this: 9, 8, 4, 7. Oops, that's not a 7. Got to watch me. It's a Monday. 9, 8, 4, 7, 5. Not a very good looking 7, but we're going to go with it. Pascals. And then I would just convert it into kilopascals, which is just 1 kilopascal equals 1,000 pascals. And then I would convert it into ATMs. And so for 1 ATM, so it's 101 kilopascals or 101.325. Okay. I like this because I like to use I like this unit a little bit better because I just like to remember my, forgot a unit there. I just like to remember my 1R value, but that's up to you. So if you want, you can go back and you can use the different R values. So you can use the 8.31, but that's up to you. So anyway, I'm going to use this for my pressure. So let's go down here and set this up. So my molar mass is going to equal G, or you can use the lowercase m, RT over PV. So the G here, they said, was 0.440 grams. And so this is where the R value comes in. So I just know I've got it memorized that it's 0.0821. And that's if I have ATMs, right? If you want to use the 8.31, you would simply do this conversion and get yourself to kilopascals. But you got to have kilopascals. And then my temperature, okay, so let's make sure we convert that, right? So 86 plus 273. A lot of times I write that directly in there, but that's really, just kind of up to you. So 359. But sometimes I write it in right when I'm writing this, but no space. So let's just do it like that. And over pressure. Okay, so pressure has to be in ATMs for this to work. If you choose to use the 8.31 value for your pressure, then you would need to have the KPA. All right, I'm just going to use the ATMs because I like it better. Up to you. All right, so, but since we have that value converted, we just need to do the math. Kind of forgot to do the math, so let me do that real quick. So I'm going to do 90. I'm going to do this right here. So I'm going to do 98,475 divided by 1,000. And then I'm going to divide it again by 101 works, but I'll use the full conversion, 101.325. And I get with, what was like 5 sig figs, 0.97187. So I got 0.97187, and that would be ATMs. Okay. And so then I'm going to put that down on the bottom. So it's 0.97187, and that's ATMs, all right? And then our volume, they said, was in milliliters, and that also isn't going to work. This problem was just full of conversions. So that's not going to work, milliliters, right? So you can't have milliliters. So we're going to have to fix that. So 179 milliliters, we got to get it to liters. So let me get some space for a conversion here. There we go. So I'll get a little space for a conversion, and it would be 179 milliliters equals 1 liter over 1,000 milliliters. And there we go. And so just move the decimal 3 spots to the left. So 0.179 liters. And we'll go ahead and put that right here. Now we can go ahead and do the math, and then we will be set. So here we go. On the calculator, I'm going to do 0.440. Okay, I had the bell there, the hazards of filming these at school. So let's just run this through. So run through your calculator. Make sure you are running it through. So 0.440 times 0.0821 times 359, and then divide it by, in parentheses, the 0.97187 ATMs times the 0.179. And then when we do all that, I got, with the, let's see, how many sig figs do we want? The 86 kind of stinks. It takes us to 2 sig figs right here, but I guess that would be right. So let's go to 74.5 or 75. So 75. Molar mass is grams per mole. So there we go. Okay, I'm going to pause it here and we'll pick it up on the next video.